Hello everyone, welcome back to my channel Saisha Tech. This is Amok Kaliwa. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we understood about gradient boosting algorithm for regression model, wherein we initially started with the comparison of AdaBoost and the random forest, that is, the boosting algorithm versus the bagging algorithm. Thereafter, we understood about the gradient boost algorithm with an example and also the mathematical implementation of the gradient boost algorithm for regression model. In today's video, we will elongate our last video wherein we will understand the gradient boost algorithm for classification model with an example. Thereafter, we will also understand the mathematical implementation of the model for the same. To understand the implementation of gradient boost algorithm for classification model, we have considered a sample data set. The sample data set consists of 4 attributes, 3 independent attributes and 1 target variable. The 3 independent attributes are whether the person likes popcorn, what is his age, what is his favorite color, and with the target attribute as whether he loves to troll. We have 2 conditions, yes or no. We have considered some of the assumptions like 0.5 as the threshold for classifying the yes condition and no condition. If the value of probability is more than 0.5, it is yes, and below 0.5 as no, which is a standard one. Now, as we have done in regression technique, for building the first tree, we had taken the average of our target attribute. As this is a classification model, here we are going to consider the log of odds ratio. Now, what is log of odds ratio? Log of odds ratio can be calculated with the formula as the probability of success to the probability of failure, which means here you can see log of 4 by 2. Here we have 4 successes with 2 failures. That is log of odds ratio, which will be our first tree. Once we have calculated the log of odds ratio for the tree, let us calculate the probability of loving troll, which can be given as e raised to odds ratio divided by 1 plus e raised to odds ratio. In this scenario, odds ratio is 0.7. Substituting this value, we get the probability as 0.7. Now, our threshold is 0.5. Hence, we can classify all the target attribute values as greater than 0.5 as yes. With that as our predicted probabilities, we can calculate our residuals for our first tree. Now, with this residuals, we can build the next tree. That is, the independent attributes are the like popcorn, age and favorite color with our target attribute as our residuals. With these values, we build our next tree. As we had done in our regression model, we had considered a learning rate. Here also, we are going to consider that a learning rate. That is, we are going to take small steps to achieve the global minima. Here we have considered 0.8 as our learning rate. With that, we can multiply all the values, that is these trees, and create odds ratio for each of the observation of our data set. Once we get the odds ratio, we can calculate the probability using the probability of loving trolls formula. That is our predicted probability. With this predicted probability, which is replacing our love trolls, we can calculate further the residuals and the process continues. This is how we implement a gradient boost algorithm for classification. Now, let us understand the mathematical approach of this whole process of implementation. This whole mathematical representation for gradient boost classification model looks confusing. Let me break down into smaller steps and explain you all the mathematical representation. Let us start with the input data. Now here you can observe the input data has two components. One, x of I, which is each of the independent observations, and y of I, the observations of our target attribute. Here we also have a differentiable loss function, which is a parameter assessed between our actual value and the predicted values. In the step 1 of our process, we initialize a model with a constant value. In our case, we had utilized the log of odds, which was previously used in the example. Once we build our first tree with the log of odds, then in the second step we are going to loop the whole process, wherein we will build the number of trees which are specified or required. Here you can observe for 1 to m, where m represents the number of trees or models to be built. With that, as we have an initial constant value of our predicted value, we can calculate our residuals. These residuals we calculate with the log of odds ratio, and with that as our new target attribute, we build our tree and utilize the tree for computing each of the observational, means x of I, that is the input parameter values of or log of odds ratio. It is as simple as predicting on our input features. Once we predict on our input features, we update our model with two components. The first component is the predictions of our previous trees, plus with some value of learning rate, we add our new predictions of the models. We iterate this process for all the models and lastly provide the output of the predicted models. This is how the mathematical representation of gradient boost algorithm for classification model is represented. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.